This presentation will show you what Reclamation's done trying to search for environmentally friendly control measures for mussels. Now, unfortunately, due to the shortness of time, I can't show you everything we researched. So this is the stuff that kind of worked. We had a lot of stuff that did not work. So if somebody wants to know what doesn't work, I can sure let you know. So what happened in the lower Colorado River is an adult quagga mussel was found on a marine dock in 2007. And once that happened, Reclamation hired Renata Claudy to come and do facility reviews for Hoover, Davis, and Parker. And they did that in the fall of 2007. And then the presentation will show what the research efforts that are environmentally friendly that we did and some of the control barriers that do work for controlling mussels. The good part about this presentation is it does show you how biofouling the little critters are. So most of the photos you see are going to be right in that little area. From down there, that's where all three of our dams are located. The best way to control quagga mussels in a facility is if you can do it in this life cycle, which is a 3-week life cycle from the beginning to pettiviliger stage. Now, why do I concentrate on pettiviliger? Pettiviliger is when a mussel grows byssal threads and they can attach. And that is a 3-week life cycle. So once they start growing a shell, they no longer are free-floating, swimming. They must attach when they get to this life cycle. So that's when they're looking for a hard surface. Very easy to control in here. If you let them become attached, this life cycle is 3 to 5 years. And this is where the biofouling and plugging occurs. So this is what they do to the environment when they get there, and this is the byssal threads. It just kind of gives you a good snapshot. The byssal threads attach so hard, it's just like epoxy. In fact, when you try to pull them off, you just bust the byssal thread. You can't break the bond of the protein. So this is a pressure reducing valve at Hoover Dam that was put in. It was 5 years old, and what's happening here is you have mussels underneath this plate. And when you don't have water washing it away, what happens with the mussel is they filter feed, and you have very corrosive biological digestion. So you have acidic and corrosive action. That's stainless steel, and that's all caused because that shaft moves up and down in this acidic corrosive mess. This is a trash rack at Parker Dam, and this is what they do. Even though the mussels are very small, they accumulate roughly in our region 55,000 mussels per square foot, and then they just plug. The trash rack that's being replaced is on the bottom here. That is a research trash rack that the Denver Technical Center Coatings Group is looking for foul-released type coating to prevent mussels, and a little bit later you'll see a slide of those. So this is a stop log that, and what's interesting about this photo is the manager of this dam, the morning this stop log was brought out of the water, I had called him and I said, "Do you have mussels at your facility?" And he said, "No." He said, "I don't." And he was really fiscally conservative. Well, the day this came out, he did retire as a facility manager at Davis Dam, because this is what they found. Now, the mussels didn't make him retire. He had submitted his stuff, but it was so ironic because he had been saying, no, 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 no. But this is what the mussels look like. The reason we show this slide is in these openings, there's drain holes, and the mussels plug in the drain, will plug the drain hole. So if you store any equipment in the water, you can no longer lift it out of the water because they plug it. So it's good to be aware of that. Plus the corrosive action. Another real problem for hydro dams is fire protection system. So these deluge nozzles will plug with debris mussels, whether they're alive or dead. They will come and then they will plug your fire system, because fire systems are usually high flow, and then your transformer coolers are right there. The mussels love cooling water because it's raw water cooling water. They plug the coolers, transformer overheats, you have fire, you have a mess on your hand. So you have to find a way to control the mussels at a hydro plant. Penstocks are another very, very big area. So our penstocks at Hoover are 30 foot. So we have 4 30-foot penstocks. So they're just big mussel farms. And so the mussels grow around this 30-foot penstock, and the first lateral is to our first generator and second, and they form in there. But when you go to take your penstock down, you have this 30-foot ring of mussels that falls to the bottom, and that'll be 6 to 8 feet of mussel debris. And I'm telling you, it is organic, smelly, stinky matter. And it really stinks the first day, and nobody wants to clean it out. The second day, it's twice as bad, and the third day, it's impossible. So if I could say anything from the debris is get it cleaned out immediately. This is what a belly drain looks like once you have the mussels in your penstock. We had so many debris mussels in our penstock, we had to shovel the mussels out into the powerhouse. Once again, very stinky and a mess. One area that the mussels really do like, and Parker Dam's seen this early on, is they're packing on their generator shafts. They're small openings, and then their drains are small. The mussels love small openings, so they will plug either your packing and smoke your packing on your shaft, or plug your drain and flood your pit. So the packing is a really problematic area because it's a small area. Mussels love to get in there. They can't get out of the packing area once they get in there because they grow to too large a size. It is a problem. So this is at our facility in Parker, this is a HV system that had raw water. It had plugged, and this is a heat exchanger. And this dam is just right. The food is right, the temperature is right, and the mussels are on steroids at this dam. And so on this heat exchanger, they just grow and they just plug it. So they needed some type of solutions, and what John Steffen is the facility manager, he put little filters on to protect packing and stuff, and we installed other systems to protect this. This is what a core facility looks like with Asian clams. So Asian clams, mussels, they're all kind of in the same family for biofouling, and they cause the same problem. Interesting at this facility, this is Gavin's Point in North Dakota, but there is no more Asian clams there because now the mussels have taken over. They compete against each other. And this is a pump that they have at Gavin's Point. It's just a pump that just got overwhelmed with mussels, could no longer pump mussels. So now we're going to discuss the research stuff really quick. So a biobox in a plant is no more than taking a side stream off your cooling water and you grow mussels on this plate. It kind of gives you an idea of what your pipeline looks like on the inside. This is a microfiltration research project that took place at Parker, and microfiltration does work, and you're targeting that pettiviliger stage. You're trying to remove the debris mussels with that screen, and then this fine micron, you want to remove the pettiviligers with it. It does work, but it's high maintenance. You can't get the mussels out of the cavity. And grass and weeds plug it. It's just not the best application. If I use microfiltration, I like to use them ahead as a strainer and really open up this area and not try to remove the pettiviliger with the microfiltration. So this is that trash rack we talked about. There's 4 different types of foul release, foul resistant coatings. This trash rack has been in Parker roughly 3 years with a rake on the system. There's a rake right there that goes over it. And they put a GoPro on the rake and they look at this trash rack and it looks pretty good. The GoPro has showed some damage from the rake, but it is not colonizing with the mussels that I've heard recently. So at Davis Dam, one of the products that Reclamation engaged in a cooperative research agreement was with Marone Biointerventions. And you may have heard it's a natural pesticide. It's a soil bacteria called Zequinox. Well, this was Zequinox that was developed by Dan Malloy in the East Coast, and Marone tried to take it to market. They had no way to get it to market, so we engaged in a research project to try to get it to market. And it is a good product. It is natural. It only affects zebra and quagga mussels. But unfortunately, the problem with Equinox is once they gave us the price of a flow-through system, this is a fairly small dam as dams go, and to have an annual cost of that high without reducing the cooling water made it cost prohibitive. We thought we would get a break on our system, but they did not, even though we spent 3 to 5 years developing it. So we no longer use Equinox. It is available out there, but it has to be made for every application because it has a shelf life right now. Another product that we tested that did work is a copper ion generator. And how this works is there's copper tubes or copper plates in here and aluminum plates, and then you just put electricity across, and the theory is you slough copper and aluminum into the water, and it's the copper that is a mussel deterrent. It did work. The biggest problem is you couldn't control it. Sometimes you would slough 20 parts per billion, the next time you'd slough 300 parts per billion, the next time 150. The best way if you're going to feed copper is EarthTech QZ, which is approved for zebra and quagga mussels. At least you can put a metering pump on it and use it for copper. Both of these products were researched, and they do work for mussels, but it is copper, so you have to be careful environmentally how you use the application. One of the things that Reclamation did is they looked at medium pressure UV, and we looked at traditional medium pressure UV, so we installed a Trojan light at Hoover, and we did our initial test. It originally did not work very well. We were going to report that. Trojan came back and they put 2 additional lamps in, and it worked because they got the dose high enough. So we had traditional UV, and why do I keep saying that? Well, we also tested another UV system called HOD, which is hydro-optic disinfection, and it has an internal reflectant. And it has a controller on it that looks at the water quality. So if the water gets dirty, it senses that, it turns up the power, and you get internal reflectant. And what do I mean by your internal reflectant? After this slide, you'll see it. But this is what it looks like. It comes in stages. So depending on how large your system is, you just add stages to it. We did 2.5 years of research on this, and this was 100% effective at very low doses for doing mussels. So this is kind of Reclamation's solution moving forward for cooling water is medium pressure HOD for cooling water. You know, it doesn't work in other applications, but if you have captured water, it works very well. This is Parker Dam, and John Steffen is here. This facility is run very well. And John does a tight ship here. It's a beautiful dam. And these lamps went in and this last year, and they've been working. They have a maintenance agreement. They work pretty well. This is how the HOD lamp works. It has this internal reflective tubing. So what's different about this one from traditional is it hits that quartz sleeve and bounces back and forth. So as the mussels come through the body, it gets repeated dose, so you can have the dose a lot lower, and when you have the dose a lot lower, then you can have a lot less energy and a lot less heat. This is what a control looks like, and this is what it looks like after in a strainer at Davis Dam using HOD. This is the control box at Parker. This is, whoops, let me back up one. This is a colonial hydroid, these things that look like trees. That's a sponge. This is what is coming in as a control. After, this is what it looks like. It's almost taken care of. There's no mussels. Colonial hydroids are almost knocked down to nothing. And this is that cooler intake. This is before, and this is what it looked like after. And I want to thank these people. All these people played a key part. I just report on this stuff. I'm involved in the research, but all these people are key. We could have never got here. And that is it. Thank you.